The topic of this episode is collision theory, a theory that describes the conditions for two or more particles to react. What do they have to do for them to react? What conditions they have to satisfy in order for the reaction to take place? There are three factors in the collision theory: molecular collisions, activation energy, and collision orientation. First, molecular collisions. The theory claims that for two particles to react, they must collide. They must come into contact to each other. So the reactant molecules, ions, or atoms, they must come in contact. We call that they collide with one another in order for a chemical change to occur. Well, pretty straightforward. It makes sense. If the two particles do not come into contact with each other, there's no way those atoms will combine to form a new chemical bond. Second aspect of the collision theory is called activation energy. Simply by colliding, it is not enough for two molecules to react. The collision must be hard enough so that they can overcome certain kinds of energy required for them to react. In other words, they have to collide pretty hard. Well, if you think about the reaction between two particles in terms of these two factors, they behave really like human beings. You know, when two people, they have feeling about each other, what do we say? We say they have chemistry. We do not say they have physics or math. We use the word chemistry. Why? There's a reason for that. Well, for two people to have feeling with each other or to fall in love with each other, number one, they have to come into contact with each other. They have to know each other. So that's number one. They have to collide. They have meet with each other. But you do not just simply fall in love with everyone you meet. So the meeting between the two must have some special thing going on so that they cause a feeling between each other. Well, for the particles, that special feeling is called activation energy. They have to collide very hard. So now to summarize, for two molecules to react, number one, they have to collide. Number two, they have to collide really hard so that they can overcome the minimum energy required for reaction to take place. It's called activation energy. Last element of the collision theory, collision orientation. Well, you can collide with each other. You can collide very hard with each other. If you do not collide at the right place, there is no chemistry. What do you mean by saying the right place? What is the orientation is talking about? So they have to collide in the correct direction or orientation. What does that mean? Let's use a reaction example to talk about this. So let's use the reaction between nitrogen dioxide and carbon monoxide to produce nitrogen monoxide and carbon dioxide. So in this reaction, a nitrogen atom is combining with two oxygen atoms at the beginning. Okay, so nitrogen in the center in the middle. Okay, then it connects with carbon. Carbon is connected with oxygen. I'm using big circles to represent an oxygen, as you can see. Okay, in the product though, so they reacted. In the product, one oxygen from nitrogen is gone. Now carbon is connecting with two oxygen now. In order for this reaction to take place, carbon must come into contact with the oxygen in the nitrogen dioxide so that they can form a bond between the two, and this bond can be broken. Do you guys understand what I'm trying to say? Maybe this picture can give us a better explanation. So this is the correct, proper orientation of collision for the reaction to take place. As you can see, there's two oxygens on the nitrogen. Here is the nitrogen. There's one oxygen on the carbon in the reactant. If they collide in this way, carbon bump into oxygen, they form a bond in between, and this bond is broken. Now we form a nitrogen monoxide and a carbon dioxide. Now let's look at these other invalid collisions or collision orientations. Here's the first case, if the oxygen in the carbon monoxide bumps into the oxygen in the nitrogen dioxide, there's no way a new carbon-oxygen bond, a bond between carbon and oxygen will be formed. So there's no reaction. Another example is, in the second case, is that, what about the nitrogen bumped into the oxygen in the carbon monoxide? Again, there's no way a new bond between carbon and oxygen will be formed. No reaction. Another case, no reaction, where carbon bumped into nitrogen from another molecule. So this is collision orientation. 3 requirements for 2 reactant particles to react. They have to collide. They have to collide very hard to overcome a certain energy level. That certain energy level is called activation energy. Number 3, they have to collide very hard at the correct orientation. See you next time.